Hi, and welcome to part 2 of our LX boiler plumbing segment. In these next few slides, we'll take a look at some piping diagrams. This slide shows the piping layout for a standalone boiler application using a single system circulator configuration. This layout is typically used in applications zoned with zone valves versus zone circulators. The LX has the ability to power 3 different pumps, labeled Pump A, Pump B, and Pump C. Pump A is the domestic hot water pump, and it's energized only during calls for domestic. Pump B is the boiler pump or primary pump, and it's energized during all calls, either heat or hot water. And Pump C is the system pump and is only energized during a call for heat. In this example, because the zoning is done with zone valves, there is typically one system circulator in the secondary that comes on for every heating call. During a demand for central heat, the boiler energizes the system circulator through the central heating CH pump output, which is Pump C. The system circulator needs to be sized to provide adequate circulation throughout the heating system. During a domestic hot water demand, the boiler de-energizes the system circulator, or Pump C, and energizes the domestic hot water circulator, which is Pump A. With this configuration, the boiler circulator is the only pump that causes flow through the boiler, and it's powered during any demand by way of the boiler pump output, which is Pump B. This pump needs to be sized according to the table that we covered in the previous section. Also, this piping configuration requires the central heating system and the domestic hot water system to be decoupled from the primary loop using closely spaced tees. Or, a low-loss header or hydraulic separator could also be used in lieu of closely spaced tees. You may also have noticed the placement of a system sensor on either side of the closely spaced tees connecting the primary loop to the heating system or the secondary. This is an either-or placement, meaning the sensor can be placed in either location. We recommend placing the sensor on the return side of the system just in front of the closely spaced tees connecting the primary loop. The purpose of this sensor is to allow the boiler to modulate to the system temperature rather than the outlet temperature. The LX actually has 3 options when determining which water temperature you want the boiler to modulate itself to. The factory default is the outlet temperature, which means the boiler will watch the temperature of the water at the boiler outlet and will modulate itself to maintain the temperature at the outlet at the target water temperature. Other options are either the inlet temperature or the system temperature, and the choice can be made within the controller settings. If the inlet is chosen, then the boiler will watch the inlet water temperature and modulate itself in order to keep it at the target water temperature. Or you could choose the system temperature and place the factory supplied strap-on sensor out in the secondary so the boiler will be able to monitor that temperature. Choosing the system as the modulation sensor means the boiler will modulate itself in order to maintain the water temperature within the system at the target water temperature. One thing to remember when using the supplied strap-on sensor to modulate to the system temperature is that strap-on sensors typically register a lower than actual water temperature in the pipe. To offset this, we recommend reducing the maximum central heating set point by 10 to 15 degrees and insulating around the installed system sensor. Without doing this, you run the risk of having higher than anticipated water temperatures. This example shows the layout most often used in applications with zone circulators, and this configuration requires the installation of a check valve located at each circulator. Because in this layout there isn't a system circulator that comes on with every heating call the way there was in the previous example, so you'll only use 2 of the 3 pump leads. In this example, there's a primary pump that needs to come on with every heating call, so that pump needs to be tied into Pump C. And during a call for domestic, the only pump that should come on is the domestic hot water pump, shown in this diagram as Pump A. During a central heating demand, the boiler energizes the central heating circulator through the central heat pump output, which is Pump C. During a domestic hot water demand, the boiler de-energizes Pump C and energizes the domestic hot water circulator, Pump A. So both Pump A and Pump C used in this configuration are responsible for water flow through the boiler and must be sized according to the minimum pump specifications for the primary pump laid out in the previous section. In this configuration, you don't use the output for Pump B because there isn't a dedicated primary pump or boiler pump that needs to come on with every call. The pump we are showing as pump C in this diagram would be considered a primary pump, so there might be a tendency to want to use pump B, which is the boiler pump, instead of pump C. If that pump was tied back to the leads for pump B, it would work fine on a heating call because it would be the only pump coming on. However, on a hot water call, both pumps would come on. Remember, pump B comes on with every call. On a call for domestic, you only want pump A to come on, so that is why the other pump is tied into pump C, because that is only energized during a heating call. You again will see the optional system sensor that we covered in the last slide, plus you will see the addition of a second set of closely spaced T's coming off the right-hand side of the primary loop to another zone that is running a lower temperature. When installing the LX as a standalone boiler, you have the option of running two central heating inputs. You'll see this in more detail in the section on wiring, but the boiler has two central heating inputs, CH1 and CH2, with CH1 having priority. Let's look at an example. Let's say you have baseboard radiators through 2 floors in a house, but you have a loop of in-floor heating in either the basement or the garage. You can lay out the zones with the baseboard as shown in this diagram as zone 1, 2, and 3, and wire your zone controller for those zones back to CH1. This will give priority to the higher temperature zones with baseboard heat. Now, for the in-floor radiant loop in the basement or garage, you can have a separate zone controller for that zone and wire it back to CH2. When programming your central heating set points, use the higher temperature set point required for the baseboards as CH1 and the lower temperature set point required for the in-floor loop as CH2. What this allows you to accomplish is that when both the high temperature zones and the low temperature zones are calling, the boiler will default to the higher temperature set point and deliver that temperature water. That is why you see the low temperature zone still requires the use of a mixing valve to mix the water down to the right temperature for the low temperature application in that zone. The advantage, however, is that if only the low temperature zone is calling, the boiler will deliver water temperatures to match the requirements of the lower temperature zone. So, instead of always generating water temperatures that exceed the requirements, then mixing it back down, when just the low temperature zone is calling, the boiler will only deliver the low temperature. So less energy is spent heating water to higher temperatures just to mix it back down, and the boiler will get better efficiencies by having a lower return temperature and getting more condensing. We recommend using the high temperature zone for CH1 in order to give priority to the higher temperature, because generally when heat is needed, it's more critical to deliver heat to a radiator or air handler than it is to heat a slab. However, you do have the option of wiring it the opposite way, using the low temperature zone as CH1 and the high temperature zones as CH2. What this would mean is that the low temperature zone would get priority, so when both zones were calling, the boiler would only deliver the low temperature water. The higher temperature zones would still get some heat, but probably not sufficient to satisfy the thermostat. Once the low temperature zone was satisfied, the boiler would then jump to the higher temperature set point and deliver higher water temperatures to the other zones. This may be a preferred method depending on your specific requirements, but generally speaking we would see the high temperature zones as those needing priority. And that concludes this section of the LX boiler plumbing, where we've taken a look at a couple of different options on how to lay out the piping diagrams. Hopefully this was helpful for you. On behalf of everyone here at NTI, I'd like to thank you very much for your interest in our products.